Is that okay?
That's fine. Okay, tell me when you're ready.
Read the electrical impulses your brain is already giving off.
Hey guys, welcome to this brief introduction to EEG. So just what is EEG anyway? Well, it stands for electroencephalogram, or electroencephalography. It's the continuous recording of electrical brain activity. And just what is this brain activity? What is it that EEG is recording? Your brain is made up of billions, actually hundreds of billions of brain cells, called neurons. The neurons have axons that release neurotransmitters, and dendrites that receive them. When the dendrites of a neuron receive the neurotransmitters from the axons of other neurons, it causes an electrical polarity change inside of the neuron. This polarity change is what the EEG is recording. It's the postsynaptic dendritic currents from the cortical pyramidal cells. The activity from one single neuron is way too small to be detected with EEG equipment, but when thousands or tens of thousands of neurons work in concert, we're in business. An area or a group of neurons working in concert is called an LFP, or local field potential. Now let's look at some of the equipment we use to measure EEG signals. First, there's the EEG cap, which has sponges to hold saline solution and metal electrodes to conduct the electrical signals to an EEG amplifier, which of course amplifies the signal strength. The data then gets sent to a data acquisition computer to be stored and analyzed. Each EEG cap has special electrodes to measure the eye muscle movement. This is called EOG, or electrooculogram. This is what the EEG data looks like as it's being recorded on the data acquisition computer. The numbers down the left side correspond to the electrodes on the EEG cap which the participant is wearing. In the actual data itself, you can see the tiny amplitudes which represents the brain activity, and the larger amplitudes represents the muscle movement such as eye movement recorded on the EOG electrodes. EEG amplitude is typically measured in microvolts, and the wavelengths are divided into four main groups, which are determined based on the frequency oscillations. These four groups are gamma, beta, alpha, and theta. When the EEG signal is time-locked to a stimulus which the participant reacts to, it's called ERP, or event-related potentials. The time period before the stimulus in an ERP experiment is called the baseline. EEG is a very effective neuroimaging technique. One of its strengths is that it is fast. EEG can record brain activity on the order of milliseconds. Another strength of EEG is that it's very safe. EEG doesn't actually do anything to the brain. It just passively records the electrical activity that the brain is already giving off. One of the weaknesses of EEG, actually its main weakness, is its poor spatial resolution. This means that the EEG is not very good at telling exactly where things are happening in the brain, at least not as good as other techniques such as fMRI. Now that we've been introduced to the basics of EEG, let's talk about how to collect EEG data. The first phase is to prepare the solution. You want to start out by filling a bucket with 1 liter of distilled water. Next, you're going to mix in potassium chloride to increase the electrical conductance. You're also going to mix in Johnson's baby shampoo to soften the scalp of the participant and decrease electrical impedance. Be sure to mix thoroughly. The second phase of collecting EEG data involves taking various measurements of the participant's head. First, greet your participant. Have them sign a consent form if needed. and explain what the experiment is going to be about. Next, you're going to measure the diameter of the participant's head. This is to find out the exact cap size which the participant will be using. The cap sizes in our lab are measured in centimeters. Once you've selected the correct cap, you're going to soak it in the solution you've already prepared. Set the timer to soak it for 10 minutes. Next, you're going to take some other measurements to find the exact center of the participant's head. First, measure from jawline to jawline. You may need to ask the participant to open and close their mouth so you can feel where the top of the jaw is. Once you've found the exact center, make a mark with crayon. Next, you're going to measure from the nasion, which is the point right in between the participant's eyebrows, to the inion. The inion is the bony part or projection of the skull that sticks out. You can feel it with your fingers. Once you've found those 2 points, hold the measurement tape. Divide by 2 to find the center, and make another mark. The 2 marks you've just made should form an X in the exact center of the participant's head. This will be important later. For now, we're done with this phase and ready to head next door to start recording. The last phase of preparation for recording the EEG signal involves getting the best possible recording from each electrode by lowering the impedances. We start by connecting the cap to the electrical recording equipment. Then, we start the software that's going to be used to record the EEG signal. We want to make sure our participant is very comfortable and that they have everything they need, such as tissues in case water happens to drop on their face, or a towel around their shoulders. Our third step in this last phase is placing the EEG cap on the participant's head. To do so, you want to spread your fingers on either side of the cap. There's an electrode right in the middle of the cap called CZ. You want to place this directly on the X which you made previously. This is a very important step. As you bring the cap down around the participant's head, you're going to bring the straps under the chin. And there are 2 holes in the cap which you can adjust underneath the participant's ears. Next, you'll adjust the cap so that it has a very snug yet comfortable fit. It's important that the fit be snug because the more the electrodes press down onto the head of the scalp, the easier electricity can be conducted to the electrodes. But of course, you also want the participant to be comfortable. There are various techniques we can use to lower the impedances at each electrode. When you look at your screen, the software may show something like this. The red dots indicate the electrodes for which the impedances are still too high. The main technique is just to wiggle the electrode. Wiggling causes the sponges to get closer to the scalp and moves the hair out of the way, which may block the electrical connection. After you're done giving a quick wiggle to each of the electrodes, your screen may look something more like this. The green indicates that we are good to go. If you have a couple of problem electrodes that are still showing red, you can give them a little bit more attention. Here's some techniques you can use. First, add some more saline solution. Then wiggle around the electrode some more. If that doesn't work, then try directly moving aside the hair to make sure the sponge underneath the electrode comes into direct contact with the scalp. Let's look at that from another angle. Just add more saline solution, wiggle around the electrode, and move aside the hair if needed. And that should do it. Now you're ready to ask the participant to start the experiment, and just press record to start recording your EEG signals.